Okay, what we're going to do in this section is we are going to look at properties of rational exponents. Now, when I'm talking about rational exponents, it's talking about these fractional powers right there. Right? So all of these properties that we talked about, this is from your cheat sheet, the bright green one. Every property that we talked about with regular number powers can now apply to fractions. So here they are. Now these are going to say, it's going to explain the properties a little bit different in different words, but they still mean the same thing. Your cheat sheet tells you exactly what to do. So with rational exponents, nothing changes. The only difficulty is that now there's fractions. So when you multiply fractions together, exponents together, if they have the same base, then you add exponents and you keep the base. Okay, same thing here, same base, 4s, right? So we can add the exponents. 5 plus negative 3, that's going to be 2. And then you could finish scoring that out if you wanted to and say that's 16. So right here, this example is 2 to the 1/3 power times 2 to the 2/3 power. Same base. Check. Okay, now we've got to take these two and add them together. So 1/3 plus 2/3. Boop, boop, boop. Calculator can help you with that. That's going to equal 3/3. And that's actually 1. So we take this base, and its new power is 1, which we know you don't have to write necessarily. So there's the answer to that one. This next one, let's see, same base, yay. Take these two powers and add them together. So 1/4 plus 1/2. Boop, boop, boop. Calculator says that's 3/4. So our answer is to take the same base, it doesn't change, and give it this power. And that's it. So nothing new, except for now it's got fractions, but you can have your calculator help you with that. Okay, then we move on to quotient. This means dividing. The rule is just that now you subtract them. The base has to be the same. And if it is, then you take these two and just subtract them. 5 minus 2 is 3. So you take your base and put the new power on there. Same thing over here. Same base. So we can subtract the power. Now be careful with subtracting powers, because notice this bottom one right here is negative. So it would actually be 14 minus negative 6, which is plus. That gives us a power of 20. So you take that base, put that power on it, and that's the answer. So applying the same idea to these fractional ones, this is 3 divided by 3 to the 1/4. But there's no power written on that top 3. Well, dun, dun, superhero says, yes, there is. I'm here. I'm just invisible. So same base. So we can subtract the powers. 1 minus 1/4. Boop, boop, boop. Calculator says, hey, that's 3/4. So we keep our same base. Give it this new power. All right, same thing. We've got the same base, so our answer is going to have a 4. Take these two powers and subtract them. 2/5 minus 1/10. Boop, boop, boop. Calculator says that's 3/10, which is your new power. So multiplication and quotient properties, still exactly the same thing. You just add the powers or subtract the powers depending on whether they're being multiplied or divided. The base never changes. We need to write a big note to remind us of that. The base never changes. Whenever you apply these properties, the base never changes. It's always the same base. Okay, the next one was the power rule. If you have an exponent, like right here, raised to a second power, this guy right here, then it's simple. You keep the base and multiply those two powers together. So when you have an exponent and it's raised to another base, you keep the base and multiply the powers, or exponents, whatever. They mean the same thing. Sometimes this guy up here is called the power, sometimes it's called an exponent, sometimes the whole thing's called an exponent. Either way. All right, one base, it's got two powers up here, a second one outside the parentheses. So the base stays the same. Multiply the two powers together, and it's x to the 10th. Right, so now we go down here to this guy. 2 to the 1/2 power raised to another power. So we've got two powers going on there, which means we're going to have to multiply them. And you can use your calculator if you want, but this one's an easy one. You go straight across. It's 4/2 or 2. So we keep the base, put the new power on here, and that would be your answer. But 2 squared, you can actually multiply that out. This is technically what the completed after the property was applied, but 4 would be your true answer. Okay, this one, 2 powers. So I've got to take the 2/3, multiply it by the 1/2, end up with 2/6 or 1/3. Keep the base. That's 8 to the 1/3, and I'm good with that answer. That can be simplified further, but we're good with it there. Okay, next properties are the 1 power. We already just talked about this one. If there's no power written, you assume it to be a 1. The 0 power, anything raised to the 0 power is just equal to 1. Whatever the base is, that thing raised to 0 equals 1. We end up coming across problems like this. The whole thing isn't 1, just this guy equals 1. So it becomes 3 times 1 times y, or just 3y. Basically, that guy disappeared. Okay, there's those properties. Now this one is one that you've seen a couple times now, but it still tends to make people struggle. So let's talk about negative powers. When you have a negative power, all you do is move the whole thing, only the one being raised to the power, to the other side of the fraction line. And when it does, the power becomes positive. So for example, here we've got 4 to the -3. Well, technically he's on top. So I'm going to change sides, and it's going to become 4 to the +3, but now it's in the denominator. And that's all the rule says. Okay, this next one over here, 1/3 times x to the -3. Here's the tricky part. 3 is not being raised to that power. It's got its own power. If it looked like this, then 3 is being raised to that power also, but it's not here. So the only thing that's got to move is this. So it's going to move to the top side, and it becomes x to the +3. And that other 3 that's just to the 1 power, he's still just down in the bottom. So in this case over here, it would have ended up being 3x in parentheses to the 3rd, and then that 1 would be on the bottom. Okay, let's look at some with fractions. 5 to the -1/2, all right? Technically, it's 5/1. To make the power positive, you jump it to the other side. So now it's 5 to the +1/2, and you put a 1 to hold the spot on top. Dun, dun. Okay, this example, it's x to the -2/3, so it has to move to the other side. Now, 2 has its own power of 1. It's not negative, so it doesn't go anywhere. There's no flipping signs, or sorry, they don't flip sides. This guy that's got a negative power moves to the top. So now it's going to be x to the +2/3. The 2 is still there. And there's nobody left in the bottom, so we put a 1. But a 1 on the bottom you don't really need to write. So that would be our final answer. So you cannot ever evaluate anything when the power is negative. You can't find 5 to the negative 1/2. It doesn't make sense until you do 1 over, then it's a positive. Okay, let's practice some of these. So this first one is, I've got one base with 2 powers. So 1 base, 2 powers. If you look back at our reminders of this, if you have a power to another power, 1 base, 2 powers, then you just multiply them. So this becomes x, and we've got to multiply 2 times 5/2, 2 over 1, boop, 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 calculator if you need to, 10 over 2, which is 5. And that becomes x to the 5th. Okay, this one, number 2 here, a little bit trickier because look, up here we've got an exponent with 2 powers. So I got to multiply the 3 times the 1/3, which actually equals 1. So on top here, now we have x to the 1, and then on bottom we still have that x to the 2/3. So this one right here was that power to a power again, 1 base, 2 powers, so you multiply. Now we're dividing. In order to divide, the base is the same, but you take these powers and you subtract them. So 1 minus 2/3, boop, boop, is 1/3. So our answer would be the same base x to the new power 1/3. Right, 1/3 came from there. This x was that same base. All right, this one, it looks like this one's a sharing one. I'm going to scratch this out just because we haven't talked about that property yet. That property is next. So we're just going to combine these guys. I've got 2 to the 3/2 times 2 to the negative 1/4. Now you have a choice here. You can move that 2 to the negative 1/4 to the bottom, or you can apply that multiplication rule that says if we have the same base and they're multiplying, that we can add these powers. So 3/2 plus negative 1/4. Boop, boop, boop. Calculator says that is 5/4. So keeping that same base, 2, and its new power is 5/4. So you can add the beginning, or you could change this to a fraction, and it would become 2 to the positive 1/4 on the bottom. And then because you're dividing, you would subtract those powers. I just prefer to add at the beginning. Right, whoo, look at this doozy. Wow, I know how to count. Look at that. 1, 6, 7, 8. Who do we appreciate? All right, let's look at this nice one. So we've got a bunch of stuff being multiplied together. We've got 4 times x to the negative 1/4 times y times negative 2 times x to the 3rd times y to the negative 2/5. So when it comes to problems like these, the number pieces can be multiplied together. That's a regular old arithmetic, right? Then you've got 2 different sets of x's. If they have the same base, then we know the tricks on how to combine them into a single exponent. Then you also got your y's here. So you've got y times y to the negative 2/5. And then you apply the rules that we know to each of those. 4 times negative 2, that's easy. That's negative 8. This is x to the negative 1/4 times x to the 3. So I'm going to take these exponents because we're multiplying. I'm going to add them. Negative 1/4 plus 3, which is 11/4. So my base, x, and my power go there. Okay, same thing with y. I've got y to the 1